Welcome to the Explainer. Today, we are diving deep, and I mean really deep, into one of the most complex, high-stakes, and frankly frustrating arenas in all of modern technology, the telecommunications cloud. We're going to unpack a massive, industry-wide headache. You know the one, the promise of 5G and instant connectivity versus the behind-the-scenes reality of why everything seems to take forever. And at the center of our story is a really fascinating open source project called Nephio, which was born specifically to try and bring some order to this incredible chaos. But listen, this isn't just a story about code and servers. It's a story about people. It's about communication, it's about collaboration, and it's about a fundamental clash of cultures between the old school world of telecom and the new world of cloud computing. So if you've ever found yourself wondering, hey, why can't I get this new service? Or why does rolling out a network upgrade take so long? Well, you're asking the right questions. So let's get started by exploring the sheer chaos that sparked this entire movement in the first place. All right, to make sense of this incredibly complex world, we've broken our journey down into 6 key parts. Think of this as our roadmap. First, we're going to roll up our sleeves and investigate the chaos beneath the cloud, just so we can all truly appreciate the scale of the problem we're dealing with. Then, once we understand the mess, we'll look at the big idea proposed to clean it up, creating a common language for automation. After that, we'll trace the evolution of Nephio to see how this project has grown from a simple idea into a mature platform. And then we get to the really juicy part, the clash of the titans, where we'll analyze the completely different and sometimes conflicting visions of the telcos and the cloud giants. From there, we'll have to tackle the AI question, because you can't talk about tech in the 2020s without separating the hype from the reality. And finally, we'll bring it all home by confronting Nephio's ultimate identity crisis, the fundamental debate about what this project is and what it should ultimately become. Okay, so let's start at the very beginning, with the core problem itself. I want you to put yourself in the shoes of a senior executive at a huge telecommunications company. You are spending billions, literally billions of dollars on next-generation 5G technology. You're out there, in public, on commercials, promising your customers the future of connectivity, right? Instant downloads, smart cities, the whole shebang. But then you go back to your office, and behind the scenes, your engineering teams, your best people, are struggling with a question that sounds like it should be simple but is anything but. Why on earth does everything still take so agonizingly long to deploy? This isn't just a thought experiment. This is the daily, grinding reality that led a whole group of people to say, enough is enough, we have to build something new. This is the reality that created Nephio. There is such a great story behind this quote. It comes from Sana, who's a principal architect at a major telco, and she tells this story about being at a company dinner. A vice president, who was actually really proud of hiring her to lead their automation efforts, just casually walks up to her, drink in hand, and drops this question on her. How come it still takes 3 months for us to deploy a 5G core? Now, he says it casually, but this question is a bombshell. It is absolutely loaded. On the surface, it's a simple question. But underneath, it reveals this huge chasm between the expectations of the business and the reality on the ground. The business leaders see the word automation on a slide deck and they think, great, instantaneous, push button, we're going to be faster than our competitors. But the engineering reality is a 3-month-long, painful, manual slog to get just one single, albeit critical, component of the network up and running. This one question perfectly captures the deep, painful disconnect between what the business wants and the tangled technical challenges that are lurking just beneath the surface of the telco cloud. This question is the why. It's the reason we're even having this conversation. So to really understand that 3-month delay, the very first thing we have to do is get one thing straight. Not all clouds are created equal. It's a critical distinction. Over on the left, you've got what we call the enterprise cloud. Now, you know this world. This is running a company website, it's hosting a customer database, a CRM, your standard business software. Now, don't get me wrong, these things are important, but for the most part, they are relatively general purpose. They run on standardized hardware, and the workloads are, well, they're simpler. But then you look to the right, the telco cloud. This is not just a different category. It's a completely different universe. It is an entirely different beast. In the telco cloud, we are not just running applications on the network. We are running the network itself as software. Think about that for a second. These workloads are the network functions that connect your calls, that stream your videos. They are incredibly specialized, they are brutally performance critical, and they have the most complex, demanding requirements you can imagine. You see, in the enterprise world, if a web page loads a second slow, it's annoying. In the telco world, a millisecond of extra latency or a single dropped data packet isn't just an inconvenience. It could mean a dropped 911 call or a garbled conversation for thousands of people at once. The stakes are just fundamentally higher. Let's start peeling back the layers of that telco complexity. And we're going to start with a term you're going to hear over and over again in this space, SR-IOV. Now, at its heart, SR-IOV is a hardware feature. It's a specification that lets you take one single physical network card in a server and, through a bit of hardware magic, slice it up so that the operating system sees it as many separate virtual network cards. So why on earth is this so important? Why is it completely non-negotiable for telcos? Well, it comes down to one word: performance. Raw, unadulterated speed. Using SR-IOV allows a network function to create an express lane. It can completely bypass the software-based virtual switch in the hypervisor and talk directly to the physical hardware. This move dramatically cuts down on latency, and it saves a ton of CPU cycles, which is absolutely essential if you want to handle the firehose of data that comes with a modern 5G network. But here's the catch. The moment you decide you need SR-IOV, and for telcos you do, you have fundamentally changed the game. You've moved away from the dream of a generic homogeneous cloud, and you've stepped into a specialized world where your software's performance is now directly and tightly coupled to very specific hardware capabilities. And that's where the complexity begins. Now, this need for hardware specialization is matched step for step on the software side of the house. And that brings us to DPDK, another key piece of this very complicated puzzle. DPDK, or the Data Plane Development Kit, is basically a set of software libraries that lets network applications process data packets at absolutely blistering speeds. And how does it do that? Well, surprise, surprise, it does it by, again, bypassing the standard path. In this case, it skips the operating system's own slow general-purpose networking stack and lets the application grab packets directly from the network interface. It's another express lane. But to make DPDK really sing, you can't just install the library. You need a whole host of other specialized configurations. You need something called CPU pinning, where you literally dedicate specific CPU cores and say, your only job in life is to process these packets. Don't do anything else. You also need to configure something called huge pages, which fundamentally changes how the system allocates memory to make it more efficient for these large-scale packet processing jobs. So you see, it's not just one thing. It's this whole stack of high-performance tools: SR-IOV on the hardware side, DPDK, CPU pinning, and huge pages on the software side. These are the building blocks, the very foundation of the modern telco cloud. So here we are. We have all these incredible, powerful technologies. SR-IOV and DPDK are honestly marvels of modern engineering. They make amazing things possible. So if the tech is so great, we have to go back to that VP's question: why does it still take 3 months? And this is the absolute crucial point to understand. The problem isn't the technology itself. The real problem, as Sonia, the architect from our story, explains so well, is the complete and utter lack of a common language. It is, for all intents and purposes, a technological Tower of Babel. You have the network function vendors, the companies that build the 5G core software. You have the cloud platform providers, the Googles, the Red Hats, the VMwares of the world. And you have the telco operators themselves, the AT&Ts and the Deutsche Telecoms. They all know these technologies are required, but they have no standardized, common, agreed-upon way to talk about them, to configure them, to request them, or to provide them. Everyone is speaking a different dialect, and the result is total confusion. And just to really hammer home the scale of this communication breakdown, let's put some numbers on it. Let's try to wrap our heads around what a large telco is actually dealing with. We're not talking about a handful of applications. A big telco is managing a vast, sprawling ecosystem of over 70, that's 70, different types of network functions. You've got the 5G core, you've got all the different radio access network, or RAN, functions. You have packet gateways, firewalls, session border controllers. The list just goes on and on and on. Each one is a complex piece of software in its own right. And here's the kicker. Those 70-plus network functions, they don't all come from one happy company that makes them all work together nicely. Of course not. They are supplied by more than 10 different vendors, each with their own unique engineering culture, their own tools, and their own proprietary way of defining their software's requirements. So now you can really start to see the nightmare. You have 70+ different functions from 10+ different vendors, all trying to land on a cloud platform that also has its own way of doing things. This is the root cause. This multi-vendor, multi-function integration nightmare is why you're looking at a 3-month deployment time. It's pure, unadulterated complexity. Now, it's easy to point the finger at the vendors, but let's look at this from their perspective for a minute. The chaos is just as bad for them. I want you to imagine your product manager at a network function vendor. You have a great product, and you have 20 different telco customers who want to buy it. Here's the problem. Every single one of those 20 customers has built their cloud infrastructure differently. They have unique configurations for SR-IOV, different networking plugins, different security policies, different everything. So for you, the vendor, every single sale turns into a brand new, bespoke, custom integration project. You have to create custom configuration files, custom deployment scripts, custom everything from scratch. And this painstaking, manual, error-prone process gets repeated for every single customer, and then it gets repeated again for every single software update you release. It is a vicious, soul-crushing cycle of customization that takes months, drives up costs for everyone, and benefits absolutely no one. Okay, so we have established the landscape. We've waded through the chaos. We understand the pain. We get why it's a mess. Now, let's turn the corner and start talking about the proposed solution. This is the moment where the Nephio project enters the story. And it's really, really important to understand this point. Nephio is not being pitched as just another tool or another platform or another dashboard. At its very heart, at its philosophical core, Nephio is an attempt to create a new way of communicating. It is an attempt to build a Rosetta Stone, a universal translator, a common language designed specifically to end the Tower of Babel problem for good. So that's a big claim. How exactly does Nephio propose to create this common language? Well, it does something really, really clever. Instead of trying to invent a brand new language from scratch that nobody knows, it leverages the one language that has already become the de facto standard for cloud orchestration everywhere, Kubernetes. More specifically, it uses a powerful built-in Kubernetes feature called Custom Resource Definitions, or CRDs. Now, what's a CRD? Think of it like this. CRDs let you add new words to the Kubernetes dictionary. Kubernetes already knows words like pod and service. Nephio uses CRDs to teach Kubernetes a whole new vocabulary, specific to the telco world. It adds words like SR-IOV interface or DPDK workload. And once those words are in the dictionary, the magic happens. A network function vendor can now express its needs in a simple, standardized text file, a YAML file, using these new words. They can just say, my application needs one interface with SR-IOV enabled and DPDK support. And on the other side, a telco operator can use the same language to describe their cloud's capabilities. This cluster has 50 SR-IOV interfaces available. And then Kubernetes, acting as the universal translator, can automatically look at the vendor's request and the operator's inventory and make the match. It's a beautifully elegant solution to a horribly complex problem. Now, an idea this big and this ambitious doesn't just spring into existence as a fully formed, perfect solution overnight. Of course not. Nephio has been on a real journey. It's been evolving through a series of official releases, with each one building on the lessons of the last. We're going to take a moment to trace this evolution, because it tells a story of how the project has steadily matured from what was essentially a proof of concept into something that is now, today, on a credible path to being used in real, live production networks. So let's walk through it. Release 1, or R1, was really about just introducing the core principles. It was about building a sandbox where the community could gather and prove that this crazy idea of using Kubernetes CRDs as a universal language could actually work. Then came Release 2. R2 was all about expanding the ecosystem. The thinking was, okay, the core idea works. Now let's prove it's not a one-trick pony. So they added support for more vendors and started tackling new domains like ORAN. After that, Release 3 focused on strengthening the platform. This was the time to grow up release. The focus shifted to improving security, writing better documentation, and hardening all the core components to make the whole thing more stable and robust. And that brings us to where the project is today, planning for Release 4. And the theme for R4 is clear and unmistakable: a relentless, focused drive toward getting Nephio ready for production. One of the absolute key goals of Release 2 was to prove that Nephio could help telcos avoid their greatest fear, vendor lock-in. Telcos have spent decades being locked into proprietary hardware vendors, and they are allergic to repeating that mistake in the cloud. So Nephio had to prove that it wasn't just a Google project, even though Google initiated it. It had to embrace a truly hybrid multi-cloud reality. And as you can see, it did. It demonstrated support not just for Google Cloud, but also for other major platforms that telcos use, like Red Hat's OpenShift and VMware's Telco Cloud. This was a crucial step. It showed that Nephio's principles were versatile and could work across the different foundational platforms that operators actually have in their data centers, which is critical because telcos almost never have a single homogeneous infrastructure. Now, looking at the plans for the current Release 4, you can see just how ambitious the project has become. They are attacking the problem on multiple fronts at the same time. You see a major focus on expanding into new use cases, like O-RAN, which is itself a huge and complex area, and even into transport networking. But at the same time, they are continuing to harden the core platform. Look at that line about security. They're aiming for an open SSF score above 8.0. That's a big deal. It's a public, transparent benchmark for how secure and well-managed an open-source project is. And then, critically, you see them pushing into areas that are absolutely essential for any kind of real-world production use. Things like service assurance and observability. You have to have those. This is the sign of a project that is rapidly maturing and getting serious about real-world adoption. All right, now we arrive at what I think is the analytical heart of our entire explainer. You see, the success or failure of a massive, collaborative open-source project like Nephio depends entirely on satisfying its key stakeholders. And in this world, there are two titans, two giants, who have very different and sometimes clashing perspectives on what Nephio should be. On one side, you have the telcos. They are the customers. They have a burning problem. And on the other side, you have the cloud giants, the companies that provide the underlying cloud platforms. Understanding the natural tension between these two groups is absolutely essential to understanding the debates that will shape Nephio's future. This table really captures the core tension perfectly. Let's break it down. Look at the core priority. For the telcos, the ultimate goal is solving their huge business problem. They want to streamline the entire end-to-end process of delivering a new service. Their biggest fear is the crushing integration complexity they live with every single day and the fear of getting locked into any one vendor. So their view on Nephio's scope is pretty simple. Please solve our problem. Now look at the cloud giants. Their priority is different. They think like architects. They want strict, clear, and flexible interfaces, what they call contracts. Their biggest fear, which is born from the painful experience of watching other projects fail, is that Nephio will suffer from scope creep and become a bloated, do-everything monolith that ultimately collapses under its own weight. So their view on scope is best summed up by that famous phrase, good fences make good neighbors. They believe clear boundaries are the only way to build a healthy, sustainable ecosystem. This quote from Bernard Tsai at Deutsche Telekom is just the perfect embodiment of the telco customer in pain. Just listen to the words he uses. He says that the big shift to cloud-native technology has forced a brand new, unwanted role upon them. They are no longer just network operators. We now have to also be an integrator. That word also is doing so much work there. It speaks to a burden they never asked for. They signed up to run a world-class network, not to become a bespoke software integration shop, stitching together complex, mismatched pieces from a dozen different vendors. And he's brutally honest about it. This new role is giving them quite a headache. This is the desperation, the real-world pain that drives their desire for Nephio to be a big, bold, end-to-end solution. And now for the powerful counterpoint. This fantastic statement from Tom Nadeau of Wind River, who's representing that cloud giant point of view. Good fences make good neighbors. He's not just using a folksy proverb here. He is referencing the hard-won, painful lessons learned from the history of open-source telecom projects, particularly a big one called ONAP, which famously tried to be an Uber orchestrator for everything, and, in the eyes of many, became too big, too complex, and too difficult to manage. The perspective of the cloud giants is that for a project like this to succeed, it needs discipline, it needs clear boundaries,
It needs to know exactly what it is and, just as importantly, what it is not. They want Nephio to pick one job, that difficult binding of function to cloud, and do that one job exceptionally well, with clean, well-defined interfaces, rather than trying to boil the ocean and eventually collapsing under its own ambitious weight.
In today's world, no serious technology discussion is complete until you talk about AI. It's the ghost in the machine, the topic on everyone's mind. So let's shift our focus and see how these two groups, the telcos and the cloud giants, view the role of artificial intelligence and generative AI in the future of network automation. Is it going to be the silver bullet that finally solves all these problems? Or is it just the latest, shiniest hype cycle that we all have to navigate? As you can probably guess by now, the perspectives are quite different. What's really fascinating is that from the telco side, we see two very different but equally compelling potential use cases for AI. On one hand, you have the vision from Daniel at TELUS. He's thinking about user empowerment. He imagines using generative AI to create powerful self-service tools. A service owner, someone who knows their business but isn't a Kubernetes expert, could just use natural language, plain English, to ask for the resources they need. It's about using AI to abstract away the crushing complexity. Then, on the other hand, you have Bernard from Deutsche Telekom. He's thinking about pure system optimization. He suggests using a different kind of AI, reinforcement learning, to create a closed feedback loop. The system could observe network performance in real time, try out different configurations, see what works, and literally learn over time to find the most optimal settings, potentially discovering configurations that are even better than what a human engineer could design. One vision is about empowering humans, the other is about letting the machines find a better way. And now, for that dose of cold, pragmatic reality from the cloud giants, summed up perfectly by Bill Wright from Red Hat. He calls it the hammer and nail conundrum. Just because you have a powerful, shiny new hammer, in this case, large language models or LLMs, it doesn't mean that every single problem is a nail. This is the voice of experience talking. The cloud providers are deeply wary of the tech hype cycle. They've seen it all before. Their approach is to advocate for elegant, well-designed architecture that carefully and thoughtfully evaluates where different types of AI can genuinely add value, rather than just shoehorning in the latest buzzword to look cool. It's a call for engineering discipline over hype. And this brings us to the climax of our story. It brings us to the fundamental, almost existential question that the Nephio community is grappling with as we speak. It's the culmination of all the tensions we've discussed, the chaos of the underlying problem, the clash between the telcos and the cloud giants, the hype around AI. It all boils down to one final, critical question about the project's very soul. This is Nephio's identity crisis. And here is that central question, laid bare. Should Nephio be a domain orchestrator, or should it be a service orchestrator? Now, these terms sound like jargon, so let's unpack them, because the difference is everything. A domain orchestrator is a specialist. It is a deep expert in one specific domain. Its job is to be the best in the world at orchestrating network workloads onto a Kubernetes-based cloud. It doesn't worry about anything else. A service orchestrator, on the other hand, is much more ambitious. It's a generalist. It sits at a much higher level, acting as the conductor for the entire orchestra. It coordinates across multiple domains, the cloud domain, the transport network domain, the security domain, to stitch together a complete end-to-end customer service. So the choice is stark. Should Nephio be a master of one critical trade, or should it attempt to be the jack of all of them? On this critical question, we have a very strong, very clear opinion coming from David Kinsey at AT&T. He doesn't mince words. He says he can eliminate the idea of Nephio as a service orchestrator right off the get-go. He's not interested in that conversation. He doesn't see Nephio playing that broad end-to-end role. Instead, he sees Nephio's value with absolute laser precision. He says the real gap in the industry, the unsolved problem, the thing that gives everyone headaches, is that specific, painful task of binding to the cloud. That's the domain where the chaos lives. And he sees Nephio's true purpose as being the perfect, purpose-built domain orchestrator for that one single critical job. Solve that problem and that problem alone. But as with everything in this space, it's not a settled debate. We get a more nuanced but equally compelling counter-perspective from Daniel Freddy at TELUS. He agrees that the idea of a single Uber orchestrator, one tool to rule them all, is probably a fantasy. He gets that. However, he suggests that the approach Nephio is pioneering, the philosophy of using a common declarative language based on Kubernetes CRDs, that is the real magic. He thinks that approach could be successfully applied across multiple different domains. So maybe Nephio itself isn't the single service orchestrator, but its foundational principles, its DNA, could provide the commonality needed for different, specialized domain orchestrators to finally work together effectively. In his vision, it's less about creating one master tool and more about creating one universal successful methodology.
So with all of these fascinating high-level debates about architecture and philosophy raging, what is the final unified message from the panel of cloud giants, the people who build the platforms this all has to run on? It's actually very simple, very direct. It's a mandate. The number one priority for Release 4 must be a relentless, unwavering focus on creating a clear path to production. They are essentially saying, enough with the theoretical arguments for a little while. Let's get our hands dirty. Let's solve the real-world, operational, day two problems that are necessary to get Nephio out of the lab and into a live production telco network. Because as one of the panelists put it so well, in the world of open source, adoption is everything. Without users, even the most brilliant project doesn't survive. And so we end right where the Nephio community is beginning its next great chapter. We are left with this final, thought-provoking question that really encapsulates the project's entire journey and its future. Is Nephio destined to be a brilliant, highly specialized tool that finally tames the specific, wild chaos of the Telco Cloud domain? Or is its true legacy something far greater, far more ambitious, to become the foundational language, the common set of principles, the Rosetta Stone for the entire future of network orchestration? The path forward is not yet set in stone, and the choices that this vibrant, passionate community makes in the coming months and years will ultimately decide. It's going to be absolutely fascinating to watch. Thanks for joining us on The Explainer.